Today's topic is current and voltage sources. Current source and voltage source. The ideal voltage source has zero resistance. The ideal voltage source maintains perfectly constant voltage across load irrespective of load resistance. Current delivered by the ideal voltage source depends upon resistance of load circuit. Ideal voltage source. So if we plot the load current IL versus load voltage VL, it remains constant, that is VL is equal to E. Actual voltage source or practical voltage source. Actual voltage source has internal resistance R ohm. Load voltage decreases as load current increases. This is a symbolic representation of the actual voltage source. Voltage E and internal resistance R. If we plot load current IL versus load voltage VL, if load current increases as shown in this graph, the VL load voltage decreases. Ideal current source. Ideal current source has infinite internal resistance. Ideal current source maintains absolutely constant current through load circuit irrespective of load resistance. Load voltage depends upon load resistance. Symbolic representation of ideal current source. If we represent load resistance RL versus load current IL, so it remains constant as shown in the graph. Actual current source or practical current source. Actual current source has internal resistance in parallel with source. Load current decreases as load resistance increases. This is a diagram of actual current source. Current I with internal resistance R in parallel with the current source I. If we plot the load resistance RL versus load current IL, the IL decreases due to current drawn by the internal resistance R. Conversion of voltage source into current source. We shall find out the values of I and R in terms of E and R, where R is internal resistance of voltage source, Rx internal resistance of current source. Connect voltmeter across each source and equate their ratings. Equating, we get E is equal to I into Rx. So this is the actual voltage source with E and internal resistance R in series. So if we convert this into current source, then we get I with internal resistance Rx in parallel with the I. Short circuit voltage source and current source through an ammeter and equate their readings. Voltmeter reads E volts, it doesn't draw any current. Here voltmeter reads I into Rx volts. Here ammeter reads E upon R amperes. In this diagram, ammeter reads I amperes. Equating E upon R is equal to I. So from equation number 1 and 2 above, it is seen that for equivalence, R is equal to Rx and E upon R is equal to I. Now consider this example. Convert following voltage source into equivalent current source. This is 8 volt with internal resistance 1 ohm in series with the voltage source. So it can be converted 8 volt upon 1 internal resistance, that is equal to 8 amperes. So current is 8 amperes with a internal resistance 1 ohm parallel with the current source. Take another example, that is 10 volt with internal resistance 0.5 ohm in series with this voltage source. So here 10 upon internal resistance 0.5, so it will be equal to 20 amperes. So current source of 20 amperes with internal resistance parallel internal resistance of 0.5 ohm. Another example is 12 volt with internal resistance 1 ohm in series. So this is 12 upon 1, that is 12 amperes, current source of 12 amperes with a internal resistance of 1 ohm in parallel with this current source. So thus we can convert the voltage source and current source.